Chapter 8, Number 1. The work done by a conservative force is indicated in the figure for a variety of different paths connecting the points A and B. What is the work done by this force on path 1 and on path 2? So we start off with the idea that we have a conservative force, and therefore the work done from A to B is path independent. There, it's path independent, meaning no matter how I get there, it's the same. And so, since one of these paths is this, and it's nice and straightforward, we find that the work from A to B is 15 joules. But we can also say, along, say, our green path, this whole path, we have the work from A to B is also 15 joules. But we can see that that is 18 joules plus the work on path 1, which I'm just going to call work 1. So we have that 18 joules plus work 1 is 15 joules, which means that work 1 must be minus 3 joules. And likewise, we're going to do the second path. The red path, which goes from B to here, and then down to here, and down to here, looks a little weird, but we know that the work done from B to A is the opposite of the work done from A to B. So that's equal to minus 15 joules. In addition, we know that it comes in sort of 3 parts, and we have sort of our given part. We know that it's also WB to A is also the work along this orange path which we know to be given as minus 6 joules, and then we add in the work along path 2, which is that. I'm going to call it work 2. And then we pick up the work from the end of path 2 all the way back to A, and that is given as minus 5 joules. So we have minus 15 joules equals minus 6 joules plus work 2 plus minus 5 joules. This is work 2 minus 11 joules, which tells us that work 2 has to be minus 4 joules.